Hello, I'm Caroline. I'm very happy to be with you today. I'm one of the co-founders of Dataveyes, and Dataveyes, we are a small studio specialized in human data interaction. So our job is to make visible and usable information contained in very large volumes of data. So we design and we develop tools or softwares that help people understand data or interact with data or develop new users with data. So we created Dataveyes 10 years ago because we are convinced that our brain doesn't work like a computer, and as humans we need some specific interfaces, like visual interfaces, to understand the complexity inside data. So that's why we are doing a lot of data visualization at Dataveyes, so like tailor-made advanced data visualizations. And we are a team of 5 people, a mix of designers and developers, and we are based in Paris, in France. Today I would like to talk about Knowl. Knowl, it's an internal tool we are working on since several months. It's a tool for mapping very large corpus of documents or very large corpus of knowledge. So we have a first prototype of this tool, as you can see, and it's a map about 50,000 scientific publications about coronaviruses. So we have a strong ambition for this tool. With this tool, we want to revolutionize the way we search for information in large volumes of documents. So that's the ambition. So now I'm going to tell you how it goes in real life and how we have been working on this. First, what was the trigger? How did we start this passion for search? When the Covid19 crisis happened, the last spring, we wondered what we can do with our expertise in data visualization, because we are not at all expert in molecular biology, neither in virology and medicine, but we are good dealing with information overload and data massification. And that was a real problem during this crisis. For example, we interviewed Ferdinand, who is a postdoctoral researcher in a research center, and he told us, during the crisis, we were flooded with an avalanche of preprint papers and information. I was stuck by the amount of data. It was impossible to digest by a human being. And he also added that we are not used to that. It's good that there is some transparency about research work, he said, but we are going to waste too much time if we have to assess all this. And in fact, available information about coronaviruses have never been so rich and accessible as it is now, because at the beginning of the crisis, lots of scientific publishers gave free access to their articles about coronaviruses to ease the research about the disease. That was a good idea. They also speed up the review process and the publication process for new articles, and that led to several thousands of new scientific papers about coronavirus being released each week. And at the end, it's one of the biggest explosions of scientific literature ever. So, what's the problem? Because it seems it's a good thing. But this practice of open science, sure, it's a huge potential, but it also introduces a new challenge, which is discoverability. Having too much content, too much material, we risk missing something important, which we will not find because it's drawn in the mass of information. So, Ferdinand told us, for example, that he's often afraid of missing an article that already exists about the subject he's working on, an article that could change a lot what he's working on. So this discoverability problem, it may have very concrete impact, and it has already claimed lives during the Ebola crisis in Africa in 2013, according to Berenice Dan. Berenice Dan, she is the Chief Medical Officer of Liberia's Ministry of Health. She published an article in the New York Times where she explained that as early as the 80s, a scientific work pointed out Liberia as having to be included in the area where the Ebola virus is endemic. And this scientific work was already warning of the risk of an epidemic, but this work was published in European medical journals, which are more confidential than the English ones, and unfortunately, it has remained unknown to local authorities in Liberia, and they were not really well prepared faced to the Ebola. This is a terrible example of the dark knowledge. The dark knowledge is this part of scientific knowledge that cannot be found, or that cannot be reached, or that cannot be used. And back to our coronaviruses examples, among the scientific publication corpuses we have been working on, we estimate that 50% of the publication we have been working on have never been quoted nor mentioned by any other scientific work. That means that 50% have not been reused by other researchers. At least 6% of the publications in our database are not in English languages, but in Chinese or Korean or Arabic, Russian, German, and so on. And those ones will probably never be founded by any American researchers again. So that's really a problem if a research work cannot be found, because maybe this work was bringing something new and very useful for other researchers, or maybe other researchers were working on the same subject at the same times, and they may have saved some precious time if they were able to collaborate. So, why do we have this problem? What are our tools today to deal with this discoverability problem? So most part of the time, researchers are using search engines like PubMed or Scopus, but also, more often, Google Search, Google Scholar. According to us and to others, those search engines are not the best way to tackle this discoverability problem. For user experience reason first. Because conventionally, the presentation of a search result, it's a paginated list. Let me ask how many of you are looking at the results located at the third page in the Google search results? And most part of the time, there are hundreds and hundreds of pages, and this means lots of results that will never be found by anyone. And for transparency reasons, again, there is arbitrariness in the way Google or Google Scholar work. The ranking algorithm is not transparent. There are some bias. For example, publications that are in English language are more likely to have a good rank, to be on the top of the list. It's the same for publications that are published in well-known scientific reviews. And also for publications that are already cited by a lot of articles. Some well-known publications, they are more likely to be on the top of the list. So it's good when you are looking for some conventional definition of a subject, or when you are looking for some quick answers, or when you are looking for something simple like a figure or a date or a cooking recipe. But it's not really the best way to tackle a problem or to take a critical look at a complex subject, or if you need to have a deep understanding of a subject, maybe that's not enough. So the third reason why search engines are not always good, it's they are not good when you don't know how to describe what you are looking for. Maybe you don't already know what you are looking for, or you don't know how to name it, or you don't know how to describe it. But for example, imagine you are reading a very interesting article about coronavirus and genetic, and you would like to find some similar publication, but that have been published several years ago. Or imagine you would like to know if there is some other work that is refuting this article you find interesting. Or imagine you want to find some other works which are using the same experimental procedure as this interesting article. Well, I wish you good luck to find this with Google. Of course, there have been some innovations in the field of information research during the last years, like faceted filters or personalized recommendations, or metadata enrichment, NLP, or even Twitter curations. But everything, this is really great, and it does help, but it's not enough according to us. Because most part of the time, it's still designed as black boxes, like magic recommendation, and it's still designed to give you a quick answer rather than giving you more exploration capacity. Design choices like the simple page of results, it's often too often it limits what you can easily access, because everyone is thinking, let's keep it simple, not too much option, efficiency is a better user experience. But we think it does not empower users in the best way. According to us, it's not really a recommendation problem we are facing. It's not about improving algorithm to give you the best 10 results. It's because we have to admit that 10 results is most part of the time not enough when you are looking for research publication, when you are trying to solve a complex problem. So it should be about improving the experience to give people access to much more information than 10 results. And it should be about giving people the right tools to be able to navigate inside very huge amount of information, to find by themselves the content. So that's the real challenge according to us. So how we have been working on this challenge. Let's describe now a few elements of our methods. So first, we always experiment with real data. For this prototype, for Knowl, We have been using 2 datasets for this first exploration. So the first one was Lens Covid19 datasets. Lens, it's an academic, independent, non-profit organizations. They package this corpus. And the second one was Cord19. It's the Covid-19 open research dataset, which is curated by the Allen Institute for AI. Second, we support our experiment with user research. We are doing interviews, we are doing user testing with a small group of experts and researchers. We are mixing the different skills in our team, designers, developers, we are working together on the same problems, and we prototype to solve problems. Rather than specifying a solution to be achieved, we describe a problem, and each member inside the team try to find solutions and to test the solution. In this project, the first problem we wanted to solve was how to do something that is good where classic search engines are not good. So we wanted to find answers to questions like how to allow users to better understand a corpus as a whole, or how to help users find something they cannot describe, or how to help users navigate very large volumes of content, or how to reduce this fear of missing out on something important, and things like that. We had a strong intuition that mapping can be an important part of the solution. It's Google Map rather than Google Search, in fact. So we are interested in the appearance of Google Map and how this technology changes users. So a book tells this story very well. I recommend the reading. It's Never Lost Again by Bill Kildare. And this quote, "No one after us, no generation to come will ever be lost in the way that every generation before was." So this was inspiring for us, and so our approach was first to try to map the publication, to give an overview of the corpus, and because data visualization, the spatialization of the information, we know that it brings a tangible and physical dimension to data, and we know that it plays a very positive role in the ability of people to appropriate data. And that's something we have observed for a long time at Dataveyes. So it helps people get a mental picture of the data, because otherwise data is something that you cannot imagine. It helps people to interact with the data, to feel able to get their hands on it. And this is the tangible dimension that brings it closer to the physical world, and it breaks the black box effect. And finally, spatialization fosters memorization. So armed with this, we wanted to demonstrate to what extent spatialization, localization could help better search in scientific publications. So first, we have been looking for the best layout to map the datasets. We produced a lot of experiments about how to position those publications in a physical space. So those are just a small snapshot of all the tests that we have been doing. So we have to imagine this dataset as a ball of clay that we try to mold to give it a shape. After all these tests, we finally kept 2 approaches. The first approach was a graph of citations links. So it's a network graph, a force-directed graph. So how does it work? Each node is a publication. The publications are linked together when they are citing each other. So we use a physical simulation where the links act as attractors, a bit as if we had balls linked together by stretched rubber bands. And as you let go, all the rubber bands try to bring the balls together, and the system stabilizes in a way that optimizes the expression of each link. So it gives an idea of the organization, the structure of the corpus according to the citation links. And we know that citations links are very important in scientific research, because science is made by iteration and refutations, progressive iteration and refutations. And we were interested in finding a spatialization mode that shows the making of science, that make visible this iterative nature of science. So with this graph, we were able to make visible the dark knowledge also. The dark knowledge in our dataset, this is the 50% articles which are not cited by any other publication, and you can see them here. It forms the corolla at the periphery of the graph, and those publications, which are not linked to anything else, they are rejected to the borders, but they remain visible and explorable in this visualization. Second approach, it's a dimension reduction map, and this is where we have been using machine learning. So here we reduced each publication to a metadata sequence. So it's a unique sequence of keywords that reflects each publication. So we use 26,000 different keywords to describe the publication, and each publication can be summarized by a sequence of 1 and 0 describing if each keyword belongs or not to the publication. So this gives us vectors of 26,000 dimensions. So it's like coordinates in a multidimensional space, but with 26,000 dimensions. So then we use machine learning algorithm. We use a dimension reduction algorithm to switch position from the multidimensional space to a 2D space, two-dimensional space. So we used UMAP algorithm. It's an algorithm in the t-SNE family, and it's this kind of algorithm. It translates proximity notion in a multidimensional space into proximity into a 2D space while preserving the topology. The idea is that two articles that have close keywords and they are closed to each other in the multidimensional space, and the idea is that they are still closed at the end in the two-dimension space. And two articles that were far away from each other in the multidimensional space, because they have no common keywords, and they are now in the two-dimension space, they are still far away from each other. So here we wanted to replicate the physical experience that you have while strolling in the shelves of a library, for example, while you can come across a book that interests you and look step by step to what's close on the shelves and find something else that will interest you and you didn't know that this was here. So at the end, we had these two ways to draw the map of the corpus, the network graph with the citation links and this reduction dimension map. And we made user tests to determine which one was the best, which layout was the best. And the dimension reduction map was really better understood without any doubt. Testers felt more comfortable with this map. They interacted with it more naturally than with the citation map. And they told us it was easier to understand and it makes more sense. So, no doubt, it was the best. But colors are important too. Between this map on the left and this map on the right, there is a huge difference in your ability to understand and to perceive something. Without colors, we would have a map without relief, where we cannot locate ourselves. And with colors, people immediately identified areas. They see the different zones immediately. So here the colors are materializing the clusters. Clusters, they are groups of publications that share the same properties, and we use machine learning again here to find these clusters. We use an algorithm called HDB scan. It's a hierarchical clustering algorithm, and it's a clustering by density. So now we have clusters. These clusters should also be named to find your way around. This is the principle of a map. You need a few known landmarks. So to label the clusters, we are looking for all the publication inside a cluster, and we extract their metadata and keywords, and we are looking for the keywords that are best representing this cluster in comparison with the rest of the corpus. So it's a feature selection technique. We also use colors to encode different dimensions of a data set, for example, the year of publication or the number of citations. So the idea is by combining these indicators with spatialization, we can see some trends appear. For example, here articles with the most citation in our corpus are more about virology, biology of coronaviruses. So I do not spend too much time on the size of the dot. Here the size is proportional to the importance of each publication. We use the number of citation as a proxy for the importance, but it can be something else. You just have to know that it's really important to give different sizes to the node, because this code, the size, it's instantly understood by users. Before anything else, they see the size, so we have seen this really clearly during the test. Finally, this map is not alone. There are also some user interface elements, and together the UI and the map that forms a tool, and this tool gives users some more feature to explore further. So I don't know if you notice, but voluntarily we have not yet put a search box inside this interface. We are keeping this for the next iteration because we want to better explore how people are finding their ways without this search box. So for the moment there is no search box, but there are filters, so faceted filters. So you can click on a filter to add it and to filter the map, so you can see directly the result on the map. You can also display the list of all the publications. For each publication you can see the metadata which act as filters. You can zoom in or zoom out the map, so each action you are doing in a panel you see the result on the map. You can also display the summary of the article, the small card for an article. You can select only articles citing the paper you are interested about or only references of this paper. And you can also display some similar articles of your selected paper. And you can also regenerate a new map with your selection. So, now the issues that concern us is how does this fit together, the search user experience and the map user experience? Because the user tests show us that users still use the map relatively little as an exploration medium. They mainly use it as a feedback to evaluate the result of the research, the result of the filters. So at the moment, we can see little rebound between map and the more traditional part of the interface. And this will be our next challenge. We still have a long way to go and progress to make to succeed in our goal to improve the research experience in scientific publication. But that's the first step. So, as a conclusion, we are good at doing complex data visualization. We are good at doing user-friendly interfaces, and we feel that we can help by providing researchers with a better tool to understand what's published about a subject. But that's not as simple. The conclusion is it's not as simple as it seems, because looking for publication with a complex UI, like this map, it's quite disturbing and unusual for most part of our testers. You can have the best data visualization in front of you, you can find it cool and sexy. That's not the proof that you will be using it instead of Google search the next time you will have to look for papers. And even if our testers find the map easy to understand and they find it cool and nice, we saw it was not easy to use for them. And it was really less easy to use than a classic search box. So at the end, how do you make them switch? How can you be sure that the next time they will be using your rich exploration tool rather than the simple Google search interface? Well, we are still at the beginning of this reflection, and we still have a lot to do to improve the prototype and to do more tests. But we hope we will have soon some more answers and some more prototype to share with you. If you have been experiencing the same kind of situation, I will be very happy to discuss it with you. Thank you.